So we're starting today's lecture, and we'll slowly go down the road and continue from where we left off last class. I hope everybody can hear me clearly.
Yes, sir.
Good. So we have seen the basic idea of electric potential last class, which came up to be this one, and ultimately from differential information we got this one. And there is a thing called capacitor. This is something that I believe I taught right after this topic. And after I was done with this topic, maybe when I was solving the worksheets, that's when I started to talk about these graphs. But for today's class, I'm going to start to talk about this graphs first, and then I'm going to get back to capacitors. So let's consider two different scenarios. So we are basically going to try to compare the electric potential, electric field strength graph between the two charged spheres, and also the electric potential between two charged spheres. So this is the first thing that we are gonna work with. So let's take it out and start working on this one. Have a look. This one. So what I need you to see in this figure, that we are having an example of two similar charges, plus Q and plus Q. Capital Q representing a bigger value of charge, plus small q is representing a smaller value of charge. The shape or the size of the spheres in this case are immaterial in the sense of their charge amount. However, physically they are this much big. So this plus Q charge is a spherical object, metallic preferably, which is this much big, and this charge is this much big. What we are trying to consider is what is happening for the electric field in between their spaces, not inside the sphere, not outside their region. So we are interested about what is happening in between their two surfaces. So simple thing, if we draw the electric field strength graph on this axis, where E is the electric field strength, R is the distance between them. And you have to remember that electric field strength was by definition given by E equals to F by Q, which essentially makes it a vector quantity. So direction of force, this is the vector quantity and this is the vector quantity. So direction of force will dictate the direction of electric field strength. I'm by potential boltesi. Direction of force will give us the direction of electric field strength, which means in this case, if we try to draw the electric field strength for two different charges over here, on which side of the y-axis should their electric field strength be plotted is dependent on in which direction do they apply the force. For example, for the sake of easier consideration, our formula was E equals to F by Q, and from here we also got that electric field strength can also be written by KQ by R square. So we're gonna try to compare this value for two different charges, and for the sake of simplicity, we're assuming that we are placing horizontal. So for the sake of simplicity, we are going to consider that we're going to move a unit positive charge. So this is not only 1 coulomb, this is supposed to be plus 1 coulomb. The plus was missing over here, because by definition we always deal with unit positive charge for the sake of universal understanding and non-confusion scenario. So if we place a unit positive charge in between these two charged particles, one is plus Q and another is small plus Q, in which direction this charge is going to experience the force. Now, what I need you to remember that in general, not essentially it's a compulsory thing, but typically the way we deal with vector quantities is that we towards right. What the hell? Sorry, kids. Where is airplane mode? There you are. All right. So the way usually we go for dictating vector quantities in a graph system or in an X system is that towards right is considered to be the positive direction, and upwards is also considered the positive direction. I'm having these lines a bit tilted because I am not used to writing in a horizontal alignment, but bear with me. So in this case, we are considering towards right as the positive direction. So try to think about it and consider the effect of the forces one at a time. If you consider the force between this charge with this +1 Coulomb charge only, forget about this one for the time being, they are going to be repelling each other because they are similar charges. This is also positive charge, this is also positive charge. So this charge is going to apply force on this +1 Coulomb charge towards right. That's going to happen. And because of this direction, we can say that this force as a vector can be considered as a positive force. And for the same reason, the electric field strength that will be produced by this charge at this location or anywhere in between this location, this is just a sample position over here. It is not essentially at the midpoint, just a sample position. The electric field strength produced by charge object A for the in between space would also be positive. This is what you can see over here, that this is shown by this line. This top line is the individual field strength produced by the plus Q charge. So what happened mistakenly over here, I mean, this thing should not exist. I mean, this labeling was aimed to be only from there. Yeah, this should work better. This is represented as EQ or E capital Q. So this is the electric field strength graph curve for the Q charge only, which means that if we consider that this thing does not exist, let's say if this thing is out of the picture and we only have this plus Q charge and this +1 Coulomb charge, and they're repelling each other in opposite direction, and these charges can go out up to infinite distance all the way. In that scenario, this top line is going to represent the electric field strength curve for the A charge object. So this is the individual field line of the A charge object, which is given by kq by r square. Q is the charge of the A object. Vice versa, if we now for this object, if we now consider that this is the field creating charge for the second consideration, where this charge does not exist. Let's say this charge is absent altogether. So this small Q charge or B object is going to exert force onto this +1 Coulomb charge, which is our test charge, and they are going to repel each other as well. Considering that this is our stationary charge, because we are trying to find out the field strength effect of this one, and assuming that this one can move, this force on this +1 Coulomb charge is going to be worked towards the left. Being a vector, that force can be defined as a negative vector. As a result, the electric field strength produced by this charge at this location is also considered to be negative. Which brings us to the graph of this one, this lower one. These graphs are drawn by hand, and they are not essentially accurate, but they are representing the possible shape. They are negative exponential graphs with a square at the denominator side. So this is the singular graph that is applicable for minus kq by r square, which is the independent graph of this charge object without the presence of object A. So these are the two individual graphs we would have if they would have existed individually. Whenever we place them towards close to each other at a certain distance from each other, and in this place we have to find out the resultant electric field strength for both of them. Now obviously you will understand that this is the vector quantity, so resultant electric field strength should be coming from the two field strength of these two things. Sorry, oops. You have to do this. Now I have given the generic symbol plus because I'm trying to find out the resultant of two vector quantities, but by virtue, if this is considered as a positive, sorry, I shouldn't have written that. I should have written this. Yes. If we consider this one to be a positive vector, which is working towards right, and this one should by default be a negative vector, which is working towards left. So that's why this was existing on the bottom side, which means basically all that you have to do is to sum up these values to find out the resultant electric field strength, which happens to be this in between curve. Now, this midpoint over here is not essentially entirely correct, because you can see very well that if you consider it to be at this point, I mean, the vertical height above and vertical height below are not essentially equal. So what is the correct shape of graph? I'm gonna pull up another figure from the Google and I'll show it to you. Don't worry about that. But
is it wrong then এই গ্রাফের শেপটা?
sorry,
এই গ্রাফের শেপটা কি তাহলে স্যার রং?
এই গ্রাফের শেপটা পারফেক্টলি কারেক্ট আছে, জাস্ট এখানে যে পয়েন্টে পয়েন্ট অফ ইন্টারসেকশন দেখানো আছে, এই পয়েন্ট অফ ইন্টারসেকশন পয়েন্টটা slightly wrong because this is the point where the resultant E, I mean, if I label this point, this graph is basically the total or resultant electric field strength. That is supposed to be 0 when you have equal field strength available from both the charges, which means this is supposed to be at a point where this one and this one, they should be nearly equal. Basically, the very basic idea of superposition of waves, what you have come across in your AS level. So in my opinion, if I judge these two waves, this is gonna be slightly on the left side, maybe somewhere over here. This might as well be our neutral point. The reason he did not prefer to draw this as a neutral point, what I believe is that he drew this curves first, but then I told the kids that because we are representing this object as a bigger charge and representing this charge as a slightly smaller charge, so the neutral point, this is called the neutral point, where the resultant force on this test positive charge is 0, EV positive charge is 0. So this point should be slightly closer to the smaller charge, because by virtue, if you think that in this ratio, this is bigger and this is smaller. And one more thing you have to also have to understand that both of these do not represent the same thing. These are the R, which are the default R from the equation. But if you try to think about the actual measurement of R, I mean, this R represents this much from the center to this point, whereas this R for this object would represent from the center of this object to this point. So each of the individual distances are applicable from the center of the charge body to that relevant point that you are trying to consider. So they are not essentially equal, although they are written in the same expression because they are generically derived from this basic expression of electric field strength. But essentially they don't mean the same value. So whenever we'll do the math, this will have to be taken into consideration, which comes in a lot of cases. We'll see about them in the worksheet. So this is the very basic graph for the electric field strength. That's point one. Interesting enough. Achha, let me just, before I move on to from this one, let me just show you an actual possible actual shape of this graph.
So ওই গ্রাফটা গ্র্যাভিটেশন পটেনশিয়ালের গ্রাফের মতন না?
Yeah, there is similarity, but there is difference as well. I'll talk about the similarity and differences in a while. I'll compare those two set of graphs as well. But for the time being, এটা individually বুঝো. I'll bring about the idea of gravitational graph as well. Don't worry. These are all your worksheet questions. You are gonna come across these questions in your worksheets. Good, good. Is there no other exclusive example? Or that's all that we have? I guess that's all that we have. So in another case, which we're going to eventually learn in our worksheet, let's discuss this over here since this is popping up anyway. This is one of the graphs that we are going to have to deal with for our actual worksheet practice. So in this curve, what you can see that we are given the electric field produced by two charged bodies, I cannot show you the entire graph, can you? I think I nearly can. Okay. Whatever the axis is. So this is not supposed to be alpha. I think this is Q. This was the another charge object. This is another charge object. So they were placed at some distance from each other. This is the individual field strength of these two objects. The question asked you to draw the combined field of these two objects. So the reason this is becoming dot 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 dot, because this is the surface point of the Q object, and the reason this is becoming dot 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 because this is the surface point of P object. So we are trying to, so the gap in between the two charged particles were from 3 micrometer through 16 micrometer. This is the space, this was the space between their surfaces. So you're trying to draw the graph for this in between space. That's why this part of the graph is being shown as dot 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 dot. Because in true case this should not be like this. But if this was then individual graph without the effect of the Q object, this graph would have continued in this shape. Whereas if Q object was producing its own field strength graph without the effect of object P, you would have this shape. So if you're trying to draw the total resultant of this graph, one of the ways we can go for it, I'm gonna try my best to draw this. Let's say over here at 3 is here at 3 mark. It's gonna be slightly lower than that. So maybe we'll start from here. Wait, where is 3? 2.2, 2.4, 2.6, 2.8, 3. Yeah, okay, this is the 3 point. And over here is gonna be continued up to this one. So I can attempt to show you a graph that would be the combined scenario. No, not this thick. Okay, so this is gonna be slightly below that. I'm drawing it to be slightly below because we have a little bit of positive value over here. So if we do the sum, here you can see this is about 1.25 divisions on the positive side. So I'm gonna reduce this by 1.25 divisions about. I'm definitely gonna reduce the thickness of this line. Okay, this is better. So I have finished the line about 1.25 thickness up because I'm trying to sum this up. And also over here, I cannot do that essentially because the 3 point, I mean, the absolute value of 3 point is not given. So I'm essentially starting from the very peak point. And the shape of the graph, damn. Duro. Sorry, kids. Okay. And so I'm gonna try to carve this up. Not sure how well can I do this. Something like that. Nope, not working. I'll have to do a couple of more trial and errors.
অন্য একটা কালার দিলে বেটার হয় কাজ দেখা যাচ্ছে না
Oh, color select করার কোনো সমস্যা না. Which color works better? Red?
Yeah, perfectly fine.
Brown? I can increase the
Yes.
thickness, but I will increase the thickness after I finish the curve. Don't worry. This is not working. Okay, never mind. Let me try to draw this graph by my hand, which is not going to be accurate, but I'll try anyway. So this curve might as well start from here. And I will try to find out where would be the intersection point. The intersection point would exist somewhere where the vertical sum of the divisions would be nearly equal. So have a look. If I slowly start to move from left to right, here we have bigger on the positive side, lower on the negative side. So you're trying to have a sum of this one and try to find out the sweet spot where they are nearly equal to each other. I think 2.1, 2.1, 2.2. I think this is the point. Have a look. Would you agree?
Yes, sir.
Have a look. Here you have about slightly above than 2. This one should be slightly below than 2, although 12 is printed here, but you can see over here that this is significantly below the 12 line. Sorry, the 2 division below the 2 division line, below the y-axis, and this is somewhere exactly crossing. So I guess this would be the line. You can also choose this one or this one as well. Doesn't matter. You would get equal marks for. There'll be acceptable range for this graph. So the way you're expected to draw this graph, your entire drawn graph should be below this line, and this gap should increase up. Damn. Can anybody guess where my wrist is?
Writing pad.
as I'm trying to draw this up. For this center part, my wrist was somewhere over here. That's the best way to draw curves. Now I'm drawing normal person and it's all becoming weird. And then I'm gonna try to place my wrist somewhere over here and around this region. And maybe I will be able to finish it. Oh no. Let me just pull this up a little bit. So so this would be the point where you would have the least gradient. It would show up like that and then slowly smooth down to reach up to your designated point. Oops. No, to this point. So something like this. This is how the graph should work out. So basically, what you're doing.
Sir, exactly where is the graph starting? On a resultant graph ta?
Essentially, what you're trying to do, you're trying to draw a sum of the value of these two graphs. You don't necessarily have to plot all these points, but if you really want to plot some of the points, you can go ahead and do this. For example, if you ask me that this procedure seems very vague and everything, okay, so I tried to maintain very close gap over here. I mean, the position where I can get one perfect gap is over here, let's say 8, or maybe here or over here. So you might as well try to denote one point over here for your benefit. So you're going to try to slowly march it through here, and then this is the point where you have 2, and then one single gap would be somewhere over here. One single gap means where do you have exactly one more? You don't actually need to plot this point. I mean, the way this graph is actually marked is that whether you have a proper starting and end point, whether your entire graph is in between this space. I mean, you are not allowed to cross this graph like that at any point. This would be wrong. Don't do that ever. The graph is essentially starting from the 3 mark, from this point. So this is the vertical starting point of the graph. I'm not showing you the actual question, but this is actually a part of the question. The reason I'm showing you this is because this is how we have to understand how the LT efficient work. You're trying to merge up 2 vector quantities which are placed in this case on opposite side of the axis, because they were pushing the test charge particle, which is this one. These 2 charge particles were pushing this one in opposite direction. That's why they are producing opposite charge behaviors. এই পার্টটা বুঝে গেছে সবার? Abiaz, go ahead.
Sir, in this case, both charges are likely charged.
Yes.
So same.
The variations come after. I'll cover the variations as well. For example, plus Q, minus Q, and the minus Q, minus Q, what happens for them? I'll cover them after.
So, but for this case, both forces are repulsive, right?
Well, these 2 objects repel each other, but we're not essentially considering how do they repel each other or whether they repel each other or not. What we are focused on this case is that how does these 2 charges, A and B, affect this test charge, which is located anywhere in between. So
test charge is positive, right, sir?
Yes.
Test charge is positive, right, sir?
Yeah, test charge is always unit positive charge, always.
Okay. So the forces, electric force that the stationary charges are exerting on the test charge, it's repulsive, right, sir?
Yes, individual forces are repulsive, yes.
Okay.
So I'm going to get into the potential graph after a small bit. For the time being, bear with me. Have a look at this graph and try to make sense with this one. Just look at this potential graph and see if you can make sense out of it. We did not draw that test charge over here, but you can pretty much assume that there exists, let me just draw it for you. Let's say there exists, oops, no. How can I draw on the, okay, I cannot draw on this one. I have to take it on here.
স্যার আপনি কি ক্যাপাসিটর পড়া ফেলছেন?
না, আমি ক্যাপাসিটর পড়ায় ফেলি নাই, ক্যাপাসিটর একটু পরে পড়াবো।
ওকে।
So let's say we can assume, for the sake of better visualization, let's assume that there exists a +1 Coulomb charge. I'm not giving force direction, but I want you to visualize and check out this graph and ask me questions.
স্যার দুইটাই কি মাইনাস? স্যার
হ্যাঁ বলো।
দুইটাই কি মাইনাস, লাইক মাইনাস কিউ মাইনাস
no.
কিউ?
This is plus q and this is minus q.
ও উপরে মাইনাস কিউ লেখার জন্য কনফিউজ হয়ে
এটা
গেছি।
plus q.
না না, উপরে ব্র্যাকেটে যেটা লেখা।
আচ্ছা আচ্ছা, এটা অ্যাকচুয়ালি ভুল লেখা হয়েছে। আচ্ছা, না সরি ভুল লেখা হয় নাই। This is a continuation line from the earlier graph. এটা কি হবে সেটা আমি একটু পরে বলবো।
ও আচ্ছা ঠিক আছে।
For the timing, forget about this one. This belongs to the upper discussion. Maybe there was not enough space, so the kid wrote over here. বলো।
শেপটা এক্সপ্লেইন করতে পারেন?
আগে বোঝার চেষ্টা করো, আমি এক্সপ্লেইন করতেছি।
স্যার
Try to use some part of your brain. I'll definitely help, but struggle so that you can learn better.
স্যার আমরা ইকুয়ালস টু তো ফিল্ড স্ট্রেংথ, আমরা কি ফিল্ড স্ট্রেংথটা কি অ্যাড করতেছি দুইটার?
হ্যাঁ, ভেক্টর হিসেবে অ্যাড করতেছি, শুধু ভ্যালু অ্যাড করতেছি না। So interesting point হচ্ছে, here comes the explanation, so everyone listen carefully. Because this is a positive charge, this will exert a force on this charge, let's say F small q towards right. This is a negative charge, let's say this will exert another force onto this positive charge towards right. I do not essentially know which force is bigger, which force is smaller, but irrespective of the position of this test charge anywhere on this line, the direction of the green arrow and the red arrow would not be different. They can have different magnitudes, but just by virtue of their type of charges, both of these arrows are going to be towards right side. Do you agree on this one?
ছোট কিউটা ডান দিকে হচ্ছে বুঝলাম, বড় কিউটা
স্যার
কোনো
বুঝি নাই স্যার।
Because বড় কিউটা চার্জ এখানে লেখা আছে -q and the test charge is +1 coulomb, so they are opposite charges, so the বড় q would attract the +1 coulomb charge towards right. So the red force is representing an attraction force, where the green force is representing a repulsive force. But in terms of universal direction, they are both working towards right for this setup.
স্যার মানে ফিল্ড লাইন অনুযায়ী স্যার হচ্ছে অ্যাট্রাকটিভ ফোর্সও কাজ করবে, রিপালসিভ ফোর্সও কাজ করবে।
Yes, because of the type of the charges being different.
স্যার রেড অ্যারোটা বুঝেছি কিন্তু গ্রিনটা বুঝতেছি না।
Look at it. What type of charge is this? Positive or negative?
পজিটিভ স্যার।
What is this charge? Positive or negative?
স্যার 1 কুলম্ব ইজ পজিটিভ।
So there is a sign over here. +1 coulomb.
স্যার
is
মানে
also-
দুইটা অবজেক্টের মাঝখানে আরো একটা চার্জ পার্টিকেল রাখা হয়েছে।
Yes, that's exactly the base of our discussion from the beginning, that we're not trying to find out their force exerting onto each other. We're trying to find out or consider how much force they individually exert on this test charge.
আচ্ছা স্যার বুঝতে পারছি এখন।
So because in this case both the vectors are working in the similar direction, so that's why both of the field strength will be positive. That's why individual curves, for example k capital Q by r square, this is also existing on the positive y-axis. K small q by r square, this also exists on the positive y-axis. So if you just add this up, we're gonna get a total summation graph, which will also exist on the positive side of the x-axis, but positive side of the y-axis. Interesting enough, here you can get a minimum point of this curve, but you are never gonna get 0. Why is it that you cannot get 0? Because the two forces are going to work in the same direction. So since they are not working in opposite direction, there is no possibility that they will cancel out each other. I mean, the basic idea works like this. If this test positive charge is moved to the left, then the green arrow length would become smaller, because bigger distance would make the force become smaller, because the Coulomb's law goes like this: F equals to k q by r square. This is the basic law of the Coulomb. So in this case, let's say this test charge is +1 Coulomb and q is your field creating charge. So if your distance is bigger, the magnitude of the force will become smaller. So if we move this test charge to the left, then the red arrow will become smaller in length, or the attraction force becomes smaller, but the repulsive force become bigger, which is happening from this point onwards. Have a look, the electric field strength is becoming bigger because the total force is becoming bigger. Somewhere in the middle, there exists a point where the force value would be minimum, but that minimum is not zero. As you slowly start to move towards this side, this will start to attract it more strongly, and the repulsion would slowly become weaker. But they will never work in opposite direction, hence the total sum can never be zero. বলো কেউ একজন কিছু একটা কোশ্চেন করতে নিছিলা?
Sir, I asked that what does the intersection of the two curves represent? I mean, in the graph, there is an intersection point beside the KQ by R square.
This one?
Yes, sir.
This intersection point represents where the electric field strength between the two charge objects, plus Q and minus Q, is minimum.
But sir, we are accentuating on the test charge, which is +1 Coulomb. I mean, how those individual charges react to that 1 Coulomb. So is this related to this intersection point? You were saying that it represents the electric field strength being minimum.
Yes. Yes. Exactly.
No, sir, I asked that, does it have any connection to the unipositive test charge one?
Yeah, I said yes exactly because what you said was entirely correct. What we are showing over in this graph is that these individual graphs are the individual curve lines, provided the other field carrying charge was not present. And they were considered, you can see over here that here is KQ and this one is missing. And here's also KQ, here's this one is missing, because we are essentially drawing the electric field strength charge. So this electric field is essentially coming from, my bad. This electric field strength in this case is actually drawn by the formula of possible force from any of these charges divided by 1, because your test charge in this case is +1 Coulomb. So individually these graphs represent their individual field strengths. Whenever you vector sum them, you get the combined field strength. So intersection point represents where the total sum is supposed to be minimum, but not zero.
Minimum, but not zero.
Yes, not zero because they are both working in the same direction. So they're not canceling each other out.
Okay, thank you, sir.
Sure. Sajid.
স্যার এখানে আমার কোশ্চেন হচ্ছে যে ও তো মানে যে +1 কলমটা আছে এটা তো ডান দিকে যাচ্ছে, সো ওর বেসিক্যালি অ্যাট্রাকশন ফোর্সও আছে, রিপালশন ফোর্সও আছে, তাহলে তার মানে কি দুইটা ফোর্স একসাথে হয়ে ম্যাক্সিমাম পয়েন্ট দেওয়ার কথা না?
দুইটা ফোর্স একসাথে হয়ে ম্যাক্সিমাম দিবে এরকম একটা পয়েন্টে যেই পয়েন্টে দুইটা ফোর্সের ইন্ডিভিজুয়াল ভ্যালু সবচেয়ে বড়, ইন্ডিভিজুয়াল ভ্যালু না, যে পয়েন্টে দুইটা ফোর্সের টোটাল সাম ভ্যালুটা সবচেয়ে বড়. The question that you need to see over here is that whether the total sum of the forces are becoming altogether maximum, because the resultant field is not coming from one individual electric field strength. The resultant field strength is coming from the sum of both of them. So I mean, have a look, try to understand. I mean, the way these graphs reduce, they are not essentially linear decreasing, they are decreasing exponentially. So they reduce more significantly in terms of value at the beginning and less significantly at their end. Likewise this one as well. So more significant drop over here and less significant drop over here. This is why you do not have where the two sums become I mean that's essentially why, I mean that's basically part of the math, that if you sum up these two numbers, you're going to get a minimum value somewhere in between. You can see it very well from the shape of this graph. I mean, if I just show you another realistic graph from this drawing, if this is less credible for you to understand. Come on. I really do not want to plot this on the Desmos. I sincerely hope I can find this somewhere. Damn it, I might actually have to draw this.
স্যার আপনি এক কাজ করুন, ওই যে আপনি যে আগের গ্রাফ নিয়েছিলেন না, ওই গ্রাফের যে লেভেলটা এখানে আছে ওইটা আপনি আবার সার্চ দেন, দেখেন তারপর কি আসে।
No, you have to level the search আসবে না। আচ্ছা, what is the question that I'm trying to answer here? What was your question? That why this wouldn't be মানে why would this point be the highest?
না না, আমার কোশ্চেন ছিল যে এখানে তো দুইটা একটা মানে দুইটা ফোর্স একই দিকে যাচ্ছে, ঠিক আছে? তো
Yes.
বেসিক্যালি ওর তো অনেক বেশি ফোর্স আছে, তো এখানে মিনিমাম পয়েন্ট না হয় ম্যাক্সিমাম পয়েন্ট আসার কথা না?
না, maximum point আসার কথা না, because the force is created from the sum of two individual forces. I mean, if you consider from here to here, let's say if you consider this segment of the graph, let's say this segment of the graph, for this part, the amount of increase that happens to the attractive force due to minus q, the decrease of the repulsive force happening from plus q, this one is much bigger. So you have a bigger decrease and a smaller increase. So for this region, your total value is decreasing. But then again, if you move from here to from this point to onwards this side, the increase due to this attraction is more compared to the decrease of this part. So you once again have the value getting increased. I mean, how much will be your total resultant is not dependent on just because they are getting added together. No, it's not like that. It's because how much their individual values are working.
আচ্ছা আচ্ছা। আর স্যার আরেকটা কোশ্চেন হচ্ছে, এখানে যেহেতু ওই টেস্ট পার্টিকেলটার চার্জটা 1 কুলম, তার মানে কি আমি বলতে পারি যে E ইকুয়ালস টু F, তার মানে এটার মানে ফোর্স আর রেডিয়াল ডিসটেন্স ভার্সেস রেডিয়াল ডিসটেন্সের যে গ্রাফ আর ওই ইলেকট্রিক ফিল্ড স্ট্রেংথ আর রেডিয়াল ডিসটেন্সের যে গ্রাফ সেম।
Yes, because I wrote it over here that magnitude wise E equals to F by 1. So if you want to replace this E by a symbol of F, obviously you have to use the unit Newton over here. This graph would have the exact same shape, but your scale and your units are going to be different.
থ্যাংক ইউ স্যার।
Sure. Mithila, do you have any question? যাদের কোশ্চেন আনসার নাই একটু হাতগুলো নামায় ফেলো so that I am a bit less confused. Ramisha, go ahead.
হ্যাঁ স্যার, ইউ সেড কি যে এফ স্মল কিউ নাকি এফ বিগার কিউ এটা আমরা জানি না কোনটা গ্রেটার, রাইট? সো আমরা জানি না কি যে কোন ফিল্ড স্ট্রেংথটা বেশি স্ট্রঙ্গার। সো যে কোনো একটা সাইড হায়ার দিলে কি কোনো সমস্যা হবে? অ্যাজ ইন গ্রাফে দেখেন এক সাইড একটু উঁচু আর এক সাইড একটু কম উঁচু, কোন সাইড কিভাবে দিব, কিভাবে ড্রয়িংটা করব, এটা নিয়ে।
Beautiful question. This is dependent on what is the exact value of the q over here. For example, in this case, by using small q and capital Q, we're trying to represent that. Let's say if this is plus 5 coulomb, maybe this is minus 10 coulomb, something like that. Magnitude wise, this was bigger. So the exact field strength present at the surface of this charge is going to be numerically bigger compared to this one. That is always a rule of thumb.
আচ্ছা স্যার, বুঝতে পারছি।
Sure. So this was the discussion regarding our field strength. Now we are going to dive into the idea of potential. One thing we need to understand that electric potential is given by the expression potential equals to work done over charge. So here W is a work done which is scalar quantity, Q is also charge which is also a scalar quantity. So potential is essentially also a scalar quantity, which means to calculate the potential, we don't have to bother about their direction because direction is not even relevant for the quantity potential since it is a scalar quantity, which means all that you are supposed to do is add up the numerical values of those two individual numbers and you are done. So since for this first figure, I have come to the first figure once again. our two charges were both positive. So the total potential would be simply the addition of these two numbers, because we can see it very well. This one would be a positive number by all means. This one will be a positive number by all means. Big or small, they cannot be zero, or they cannot be, neither of them can be negative, because they are both positive numbers. K is a constant, which is also positive. R is a measurement of distance, which cannot be negative. So the individual values of KQ by R, or this KQ by R, they are going to be positive as well. So in this case, if you consider the value of potential between two positive charges, the entire potential would be altogether positive for their individual values. So this is the potential graph for the big Q charge, and this is the potential graph for the small Q charge. They both exist on the positive y-axis because their individual values will always be positive, because they are both individually positively charged. The product cannot give you a negative number. So to find out the total potential, you just simply add these up and you're done. And if you consider the other graph over here, where we have two opposite charges, have a look. Here, if you consider that this is the negative charge. So if you place this thing into your equation, I mean, here we intentionally gave a minus sign to signify that whenever we'll do the calculation, we'll replace the magnitude of Q over here. But just to make sense that this number or this quantity is supposed to be negative, we have shown this as a minus sign. This minus is basically, I mean, it would have been better if we did not write it like this. It would have been better if we did write it in this fashion, maybe minus K, sorry, oops. It would have been better if we did write this thing like this, K into minus Q divided by R. That way you would understand that it is not by default negative, because Q is negative, the total product of this quantity is also negative. That's what brings this curve on the negative y-axis of the potential versus distance graph. Similarly, this KQ by K small q by R, this exists on the positive side. And now because these two variables are on two opposite sides, it is possible to add these up and find out a certain point where the graph can be zero. So this is what we call the equipotential. This is what we call the zero potential line. Or in other words, what I can tell you that if there exists a zero potential line, which I'm going to use dark blue, many of you are thinking that are these 2 points at the same location? I'm going to answer that in a bit. So hold your horses. Let's not rush to any conclusions. So let me show you. If I draw a situation like this, let's say here this graph is nearly correct, because this positive y side and the negative y side are nearly equal to each other. So this graph is almost correct. And you can see over here once again that because Q was the bigger magnitude charge and this one is the smaller magnitude charge, so the zero potential line, so this is basically 0 volt. Okay, for this entire region this is negative voltage, for this entire region this is positive voltage. That's how it's working. So if I give you some numerical values without any further calculation, just assuming these numbers, let's say at this surface the voltage is, let's say, plus 100. As you slowly move from here to here, your voltage is going to reduce. Let's say over here it is plus 75, plus 50, plus 25, maybe 0. Now you might wonder, sir, apni to ekhane linearly barai dilen. Well, linearly korte parbo na, because this graph is essentially a curve. So this voltage is going to reduce non-linearly, or in the idea of this entire sum value. So it's going to be the resultant, or not resultant, the numerical sum of two individual exponential graphs, inverse exponential graphs. So here on this surface, you're going to have a highest positive voltage, and it's going to reduce gradually to reach to 0 volt over here. This is going to be a 0 voltage line, or you can say this is an earth potential. 0 voltage has another name, earth potential. It doesn't necessarily mean that it is this location is connected to earth. No, 0 volt is named as earth potential sometimes. And then as you go further down this line, your voltage is going to slowly become negative, further negative. And because this was a minus 10 Coulomb charge, essentially at the surface of this charge, your magnitude of your negative voltage would be magnitude was much bigger than this. Maybe since I have already shown these two values as double, so without any further calculation, just to make sense with you, maybe I can write that at this surface, this one might as well be minus 200 volt. So for the scenario that I'm trying to show you, that the total field that exists between these two charged particles surfaces, these two charged sphere surfaces, that potential has a total magnitude of 300 volt. Why 300 volt? It means that if you consider the total voltage that any charged particle would have to come across to cover this entire distance from the surface over here up to the surface over here, it would undergo a total change of potential of this much. Which brings us to another interesting idea, is that it's pretty interesting. I mean, interesting idea that if you place, before I get into the interesting idea, did you all understand the idea of 300 volt, everyone?
Yes, sir.
Ji, sir.
No, sir. Can you explain again?
I'm sorry.
Can you explain that again?
I am assuming that at the surface of this positive charge, the voltage was plus 100 volt, and somewhere over here where the voltage graph actually intersects, the combined voltage graph cuts the x-axis. Here we have zero potential or 0 volt, so it reduced to 0. And then from here, it is gonna start reducing further, or you can say it's gonna increase in the negative direction. And on the surface of this minus q charge is gonna be minus 200. I'm assuming these numbers are not essentially calculated, just to make sense with you. So the total potential difference between the surface of this charge and the surface of this charge, the total potential difference is 300 volt, because here you have plus 100, you have minus 200. So that's the total difference.
Oh, okay. Thank you, sir.
Sure. So one other thing is that, I mean, which is pretty interesting, that if we place a stationary, let's say if we place a stationary, let me choose a different color, positive charge over here, what's gonna happen? Think. If I place a stationary positive charge over here, irrespective of the value, I mean, I'm asking you kids to speculate its possible movement after we place this positive charge over here and allow it to move. How is it gonna move?
রাইট সাইডে যাবে,
And
মানে ও হচ্ছে গিয়ে বেসিক্যালি অনেক তাড়াতাড়ি রাইট সাইডে যাবে, তারপরে তারপর আরো তাড়াতাড়ি যেতে থাকবে।
so are you saying the speed is gonna be fast at the beginning, then it's gonna slow down? I mean, the speed is gonna be less, and then the speed is gonna increase once again.
হ্যাঁ।
Okay, that's exactly why you're wrong. I'll tell you why. Just give me some moment. You are correct for the direction, you are wrong for the magnitude. Kids, try to understand. If we do place a positive charge over here in this position and allow it to move on its own from this point, I mean, basically, if you release a positive charge over here, this object is going to experience a force towards right throughout its entire motion. That resultant force is going to be towards the direction without a doubt. But what about the value of that force? That is dictated by this curve. Do you see? You have a reducing force for this segment. You have an increasing force for this segment. What does force affect? Does force affect velocity, or does force affect acceleration? Directly.
Acceleration.
Think about it. Force directly affects acceleration, which essentially means for this entire journey from this point all the way up to the surface of this negative charge particle, all the way up to here till it gets merged over here or hits this particle, whatever. For this entire journey, speed will increase. Speed will never decrease, or speed will it will never slow down. It will always increase. But for this segment, it will increase at a decreasing rate. For this segment, it will increase at an increasing rate. So if I try to draw the velocity time graph of this particles of motion from this starting point all the way to the right, let's say if I try to draw the velocity time graph for this much segment, I mean, let's say this much segment, it is going to be increasing at a decreasing rate, because initially you're going to have a very high acceleration, then your acceleration is slowly becoming less and less and less, but it's never becoming zero. So this line should never become horizontal. It should still have some gradient left. And then from here to here, the force is increasing, which means the acceleration is going to increase as well, which means this line from this point onwards is going to increase, keep on increasing, but then the gradient is going to increase ever. Just to make my point, I have drawn a very large line to represent the increase of a gradient for over a long distance. This is a sketch drawing, not essentially a plotted drawing. But what I want you to understand about the shape of these velocity time graphs. I shouldn't draw velocity time graphs. This is velocity versus distance graph, my bad. Because this axis was distance, so this should be also distance. See if it makes sense. If I just summarize this whole graph in two single sentences, is that from the starting point to the minimum force point, the acceleration will decrease. So VT graph will be losing gradient. From this point all the way up to the minus q charge surface, the acceleration will increase. So VT graph will be gaining gradient. So check this out if this information makes sense with you.
Sir,
we
Sir,
consider
স্যার ভিটি গ্রাফ আঁকলে কি হইতো?
কোনটা?
মানে এটার ভিটি গ্রাফ যদি আঁকতেন তাহলে কি হইতো? মানে শেপটা কিরকম হতো?
অ্যাক্সেলারেশন টাইম গ্রাফ?
না, অ্যাক্সেলারেশন না, ভিটি।
কোন
ভেলোসিটি টাইম গ্রাফ যদি আঁকতাম তাহলে কি হইতো?
ভেলোসিটি টাইম গ্রাফ আঁকলে কি হইতো? Well, for that's very difficult for me to say because well the graph object is actually ever increasing in speed. So well, I can definitely say one thing that for the first, I mean, as long as the object is gonna travel between this segment, it's gonna have this part of the VT graph. আচ্ছা আমি তো ভুল করতেছি অ্যাকচুয়ালি, এটা অ্যাকচুয়ালি ভিআর গ্রাফ হবে না, এটা ভিটি গ্রাফই হবে, কারণ আমি তো এখানে অ্যাক্সেলারেশনের কথা বলতেছি। I'm considering m as an acceleration. So if I want to represent the gradient as an acceleration, this should be time. My bad. It r hobe na. Sajid, thank you for correcting me. Intentionally or unintentionally doesn't matter. I was wrong over here. This shouldn't be VR graph. This should be VT graph because I was talking about acceleration. Unless I draw them as VT graph, where does acceleration come from? My bad. Thank you. I appreciate that. My bad. This is correct. The earlier one was not. Coulomb, এই পার্টটুকু বুঝা গেছে কিনা? I'll take questions one by one. So yeah, Fardin.
Sir, I'm a bit confused about the second graph. Like, sorry, দুইটাই তো আপনার electric field strength graph, right? Graph curve. So second টা তো আপনার নেগেটিভে কেন যাচ্ছে? আমি এটাই বুঝতেছি না। I'm getting confused. Second. হ্যাঁ স্যার,
এটা field strength graph না। এটা হচ্ছে এই সেটআপের জন্য এই সেটআপের জন্য পটেনশিয়াল গ্রাফ, এই যে v ভার্সেস r, this is a potential graph and this is the field strength graph.
But আপনি বলেন না পটেনশিয়াল গ্রাফ আপনার স্কেলার হবে লাস্ট লাইক
হ্যাঁ এক্স্যাক্টলি, পটেনশিয়াল গ্রাফ স্কেলার হবে বলেই তো আমাদের এখানে এই গ্রাফটা পজিটিভ ওয়াই অ্যাক্সিসে আছে, এই গ্রাফটা নেগেটিভ ওয়াই অ্যাক্সিসে আছে, কারণ এই কিউ চার্জটা হচ্ছে পজিটিভ চার্জ, যে প্লাস কিউ, আর এই
সরি কেটে গেছিল স্যার, আবার একটু রিপিট করতে পারবেন? কেটে যাচ্ছিল।
শিওর। পটেনশিয়াল গ্রাফের এই গ্রাফটা হবে পজিটিভ ওয়াই অ্যাক্সিসে আর এই গ্রাফটা হবে নেগেটিভ ওয়াই অ্যাক্সিসে, কারণ হচ্ছে this small q is a positive charge whereas this is a negative charge. So if you just do the math, positive into negative divided by positive, you get it altogether negative number. So you cannot essentially so that's why this graph belongs to the negative y-axis, not because of direction but because of basic value calculation involving the sign of the charge. That's it.
Oh, sir. Thank you, sir.
বুঝে গেছে?
হ্যাঁ স্যার, ওইটা কনফিউশন।
মুগ্ধ বলো।
স্যার ভিটি গ্রাফটা যে আঁকলেন ওটা কি 1 কুলম্ব চার্জের জন্য?
Yes. না 1 coulomb na. I brought about a new charge, any random value of charge which are represented by this orange particle. Any random positive charge irrespective of its value, if you place it in this location somewhere in between this in between this line, but if you place it over here somewhat on the left on the 0 volt line, then how is it gonna move?
কিন্তু স্যার 1 কুলম্ব দিলে ভালো হতো না, মানে ইলেকট্রিক ফিল্ড স্ট্রেংথটাই ফোর্স হতো তখন।
Yes, you very well could. I mean, I could have very well given the I mean, if you consider that আমি এখানে random value charge না বসে 1 coulomb charge বসাবো, তোমার গ্রাফের শেপ সেমই আসবে, শেপ ডিফারেন্ট হবে না।
আচ্ছা স্যার, থ্যাংক ইউ।
Sure. Abiaz.
Sir, in the second graph of electric potential.
Potential. Yeah, go ahead.
At the null point, is that the point where no more energy will be given out or taken in by the object, in whether at that point?
That's a very interesting question. I love that you asked this question. earth potential for an electric field practically resemble infinite distance. 0 volt represents for an electric field infinite distance apart. So this 0 volt position is sort of a mimicked version of infinite distance. Or in other words, I can tell you, let's say, if you want to measure the electric potential of this charged body at its surface, let's say one of the ways we can do this by moving +1 Coulomb charge from actual infinite distance from the left all the way up to its surface and measure the amount of work that was required. Or you could place +1 Coulomb charge right over here and allow it to move through this much and measure the amount of work done that you have to do for that movement. Either way, you would come up with the same result. So this 0 potential line is basically a, what can I say, cheaper version of infinite distance. Do I make sense anyhow? I mean, the word
almost, sir, because like
the word cheaper
potential
is
energy.
it's a trickier version, or it's a much easily obtainable version of 0 potential. Because theoretically, 0 potential for a single charge body should exist at infinite distance. But we can theoretically calculate that, but we cannot practically replicate that. If you want to practically replicate this, this is one of the practical ways by which you can achieve that. Does it make better sense anyhow?
Almost, sir, but potential energy, you can't measure like total potential energy. You can only measure changes in potential energy, right, sir?
Yes, but once you measure some change from 0, the amount of change is basically the value. That's the beauty.
So that's the benefit of this.
Exactly.
Okay, sir.
Mucha.
Thank you.
Okay. So that's about the pair of graphs over here. In your actual, yeah, Rafid, go ahead.
I was asking যে এখানে কি আমাদের রেফারেন্স পয়েন্টটা কি is it this 0 potential line নাকি হচ্ছে এখানে ইনফিনিটি কে আমরা রেফারেন্স হিসেবে ধরব? আমরা যদি বলি work done to move a unit charge from infinity towards that point is defined as the potential at that point.
For definition, we'll always use the idea of infinite distance, because whenever we are trying to define an object, we consider a single charge sphere or single charge particle to be isolated in free space. So our system is built up with that charge particle and nothing around. And the test charge that we are trying to bring, sorry, nothing around us, my bad. That test charge, and at end also one unit positive charge that we are trying to move from infinite towards that particle. So for the definition, we're going to also always use that. But if you are trying to measure it practically, that's where this kind of setup comes in handy.
তাহলে এখানে এই ফিল্ডের মধ্যে when we talk about any potential আমরা সব সময় এই পয়েন্টটা থেকে অন্য একটা পয়েন্টের potential difference we mean that, right?
No, not essentially. For example, I mean, if I say that the potential of this location on this surface is +100 volt, this means this is absolutely +100 volt, because in our discussion we have defined 0 volt over here. If this was not the case, if I take a random scenario, let's say if I go for a random scenario for a free charge particle, let's say a free charge particle was over here and there was no resultant field around, only this one was available, and let's say from infinite distance you are slowly measuring up the potential. Let's say this is a positive charge, and then essentially we define that the 0 volt is located here. Compared to this one, we're going to have the potential increases as you slowly go further, and maybe at this surface we're going to get +100 volt. This +100 volt is an absolute value measured from 0 volt. So this +100 volt doesn't mean that this +100 volt is from -50 to +50 or from -20 to +80. Not like that. The voltage of a certain charge particle at a certain distance from itself is given by kq/r. This value is absolute with respect to infinite distance or 0 potential.
Yes, sir.
বুঝা গেছে?
Yes, sir.
আচ্ছা, অরুণিমা তুমি হাত উঠাইছিলা, পরে আবার হাত নামায় ফেলছো. Did you get your question answered? That's why.
Yeah.
Okay, beautiful. So that was for the graph manipulations. আচ্ছা এখন আমি আরেকটা কোশ্চেন তোমাদের আলাপ করি যে কোশ্চেনটা তোমাদের মাথা বগল করবে, এটা এখন আমাকে বগল করে। সেটা হচ্ছে should this point and this lowest point be located at the same distance in between them? What do you think? The location of lowest potential and the location of lowest electric field strength and the location of zero potential, should they be the same point?
No.
Well, you can be, I gave you an answer or yes or no, but you gotta have some sort of explanation for that. Everyone think about it.
Like
কোশ্চেনটা বুঝো, সেটা হচ্ছে যে যেই পয়েন্টে আমাদের ইলেকট্রিক ফিল্ড স্ট্রেংথ মিনিমাম হয়েছে, the lowest point of the resultant electric field strength graph, should that location, which means, or I mean distance in between that location, coordinate of that point, should that location be the same as the zero potential point?
স্যার এখানে তো আমাদের চার্জের অ্যামাউন্ট ডিফারেন্ট না দুইটার পার্টিকুলার।
Yes.
So shouldn't that be the reason actually why it won't be? Nah.
Math, Shubhro, maths. Think through maths.
স্যার যেখানে মিনিমাম গ্রেডিয়েন্ট হবে ওইখানে না মিনিমাম পয়েন্টটা হবে ইয়ের।
Is that supposed to happen? Check this out. Interesting information.
Yes, sir.
E was given by minus dV by dr, right? Or was it V was given by minus dE by dr? Which one was it?
পরেরটা
Let's have a look.
ফার্স্ট এরটা
Let's have a look. Just to convince you of this fact.
First it, sir.
Take a look. E is given as minus dV by dr. Not the other way around. This is very interesting and this is very, very important at the same time. Why? Let me elaborate this. This is gonna be a bit mind-boggling. I mean, it still boggles my mind. I don't know why. Maybe you guys can help me, but I have a reason to explain this in a way that should make sense to you. I hope it makes sense to you. I would say this equation is true. This equation is not true, which means the location where dV by dr becomes 0, that should also represent zero potential, which means this relationship works for this set of graphs. The location where your VR graph has the lowest point, or where the gradient of this VR graph is 0, that point and this equipotential point should be same. I'm going to write this equation over here so that you can visualize it. V equals to minus dV by dr. Minus essentially only works for value location. So you can, for easier thing, you can disregard the minus. But if you just think about the value, কি লিখলাম আমি? তোর E equals to minus dV by dr. Yes. So what I want you to understand that the gradient of VR graph, where the gradient of the VR graph becomes 0, logically that should be the exact point where the electric field strength is also 0. Which means if you consider a scenario like this, where you do have a case where the voltage potential versus distance graph does undergo a 0 resultant point, let's say somewhere over here, this should be over above this point, but disregard the curvature of the kid, curvature of the drawing of the kid, my bad. I'm sorry. Oops. So location where the potential, no, the video is not lagging. I was just smirking for a while. So the location where the gradient of the VR graph becomes 0, that's where the electric field strength should also be 0. So this relationship is applicable for these two graphs perfectly. This works. But should the opposite relationship work over here? I mean, can you apply in the same manner that try to have a good look over here. এই গ্রাফে কোথাও কি dv by dr 0 হচ্ছে? Have a look. This is decreasing, 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 having a cut across the x-axis. Then once again, it is increasing in gradient magnitude. Is the gradient of this resultant V graph, is it ever coming across a point where the gradient is 0? Is it?
No.
It is not.
Yes, sir.
So which means this relationship is not applicable here because this relationship is not true. So this point would not essentially represent this point, but this lowest point will essentially represent this point. Get that?
Point of inflection.
Yes. Yes. Yes.
Probably.
Exactly. ওই পয়েন্ট অফ ইনফ্লেকশনের জন্য আমাদের এই dv by dr এর ম্যাগনিটিউডটা কত আসছে? 0 আসছে। dv by dr এর ম্যাগনিটিউড 0 মানে হচ্ছে e এর ভ্যালু 0. দ্যাটস ওয়াই এই গ্রাফ থেকে এই গ্রাফের এই 0 পয়েন্টটা ম্যানিপুলেট করা পসিবল. This should be with the same point. In which case applicable? When they are both like charges. When they are both like charges. But if they are unlike charges, then this is not applicable. এই ইনফরমেশনটা কি বোঝা যাচ্ছে কি বলতেছি?
স্যার নিচের গ্রাফটা যাবে?
বুঝি না, একবার বলো, জোরে বলো।
মানে নিচের গ্রাফটাতে একটু যাবেন, ওই নিচের পটেনশিয়াল গ্রাফটাতে।
Sure. This graph looks messed up. I tortured them long enough. বলো।
না স্যার, ভাবতেছিলাম যে ওই 0 পয়েন্টটা প্রবাবলি হবে, কাজ ওই ইনফ্লেকশন পয়েন্টটা যদি ওখানে 0 হয়ে থাকে তাহলে
না, এটা হবে না। এটা কেন হবে না বলতেছি সাজিদ, সেটা হচ্ছে এই ইকুয়েশনটাকে তুমি যদি সাইজ করো, ইউ আর গোনা গেট দিস ইন্টিগ্রেশন অফ ই dr ইকুয়ালস টু v। সামনে অবশ্যই একটা মাইনাস থাকবে, ঠিক না?
জি স্যার।
ঠিক আছে, এটা যদি ইন্টিগ্রেট করো, ওইখান থেকে তুমি ভিটাকে 0 বসায় ই এর একটা পসিবল ভ্যালু বাই করতে পারো। বাট থিংক অ্যাবাউট ইট, যখনই তুমি ইন্টিগ্রেশন করবা, should that e be directly related to the gradient or should that be e be related to the area you're integrating?
Area.
Exactly. That's exactly why. That's further down the line discussion, which is you're not gonna ever have to use this. I'm just showing you this to make sense with you mathematically. That because this is true for this graph, that's why you cannot have these 2 points to be same location wise. But you can have that relationship working out over here because that works with gradient, and gradient being 0 is perfectly applicable for the point of inflection of a curve.
আচ্ছা
স্যার ম্যাথমেটিক্যাল পার্টটা একটু রিপিট করবেন।
ম্যাথমেটিক্যাল পার্টটা হচ্ছে e equals to dv by dr। তার মানে কোন একটা সার্টেন গ্রাফের জন্য যদি dv by dr অ্যাকচুয়ালি 0 দেখা যায়, যেই পয়েন্টে এই ঘটনাটা ঘটবে সেই এক্সাক্ট পয়েন্টে e এর ভ্যালু 0 হবে। সেটা কোথায় দেখা যাওয়া পসিবল? সেটা এইরকম একটা গ্রাফে দেখা যাওয়া পসিবল যেখানে আমাদের দুইটা চার্জই হচ্ছে লাইক চার্জেস। সো ইয়োর পটেনশিয়াল ইজ গোনা বি অন দ্য সেম সাইড অফ দ্য horizontal axis. There is going to be positive or negative. Negative কোন কেসে সেটা বলতেছি। So in that case you can have a minimum point, or you're going to have a point of inflection for this curve. This is the point where dv by dr equals to 0. See if you can agree.
Yes sir.
This is the location. Let's say this is the location. I mean, where this is supposed to cross over here. So I'm having a curved line drawing. Okay, let me use a different color. Let's say dark blue. So let's say this is the point. Okay, let's say this is the point where dv by dr equals to 0, which means logically this will also be the point where e equals to 0, because e equals to dv by minus dv by dr. This is possible to apply for this scenario where your VR graph does have a point of inflection. But in cases where your VR graph does not have a point of inflection, for example, for this case, where your two charges were opposite in their type, one was positive charge, another was negative charge, you do not have a point of inflection. So you cannot apply that same logic vice versa. Arman, বুঝা গেছে?
স্যার
স্যার তার মানে হচ্ছে স্যার
আচ্ছা হোল্ড আপ এক মিনিট, আরমান বুঝা গেছে?
জি স্যার।
আচ্ছা হ্যাঁ অরুণিমা বলো, রাফিদ একটু পর তোমার কোশ্চেন। হ্যাঁ অরুণিমা বলো।
স্যার তার মানে হচ্ছে যদি দুইটা একটা যদি পজিটিভ চার্জ হয় একটা যদি নেগেটিভ চার্জ হয় তাহলে E equals to minus dv by dr, this is not applicable, তাই তো?
ওয়েল
এরকম কিছু
বলতেছি E equals to minus dv by dr is a true equation. This should work out in every case. But whether you can apply this equation to get to some logical further deduction is dependent on whether you can actually apply that equation for a given scenario or not. মানে I cannot say that a scenario তে E equals to minus dv by dr applicable না, I cannot say that, because like I said that এই equation আমি minus dv by equals to minus dv by dr directly applicable না করলে আমি সরাসরি ইন্টিগ্রেশন করে অ্যাপ্লাই করতে পারি। This is an empirical equation which is applicable everywhere, but can you use the idea of gradient being zero, making the electric potential zero for this graph? It's not, I'm not trying to tell you whether the formula is correct or not. I'm trying to tell you whether the formula is applicable or not. Get the difference? E equals to minus dv by dr is a generic equation. It is applicable for all sorts of scenarios. But can you apply that information to get a projection on where the E is supposed to be for this graph? The answer is no, because in no part of this VR graph is it having a zero value. Is the gradient of this VR graph ever becoming zero? The V is becoming zero, but is the gradient becoming zero ever?
No.
That's why you cannot use this information to get a projection of the E point for the other graph.
কিন্তু স্যার এখানে তো ইও জিরো হচ্ছে না, তাই না? We are getting a minimum value for E.
হ্যাঁ, so once again same thing, সেটা হচ্ছে যে তার মানে কি এখানে যেই পজিশনে আমাদের V টা মিনিমাম হয় সেম পজিশনে আমাদের E টা মিনিমাম হবে কিনা, মানে হচ্ছে if I just revert the logic, মানে এখানে আমাদের মানে এখানকার লজিকটা কি ছিল? এখানে লজিকটা ছিল হচ্ছে যে পয়েন্টে E টা জিরো হবে ওই পয়েন্টে মিনিমাম হবে। This was applicable for this case. So if we just reverse the logic, okay fine, these two graphs looks like this, and here we have a graph like that, and vice versa we have a E versus R graph which looks like this, and V versus R graph looks like that. So if you just think about the shapes and just do the reverse in your head, is that applicable? The answer is no.
Oh, acha.
Yeah.
Sir, why though?
Go ahead.
স্যার এই যে এটাই যে why is that no, এই পার্টটা একটু আরেকবার রিপিট করবেন?
Why is that?
মানে যে এখানে কেন যে মিনিমাম হলে এটা জিরো না, এটা আরেকবার বলবেন? লাইক এই জিরো যেখানে হচ্ছে আর মিনিমাম যেটা লাইক ইন দ্য ই গ্রাফ ই ভার্সেস আর এন্ড ভি ভার্সেস আর এ যেখানে জিরো, এটা তো সেম পয়েন্ট না, রাইট?
হ্যাঁ,
এটা একটু আরেকবার বলবেন যে why is that so?
Because if this has to be derived, this is the logic that you need to fulfill. This logic works like this, that the gradient of VR graph where this part becomes zero, that's where E can be zero. First of all, E is not zero in this graph at all. So it's not supposed to be applicable. But then again, just by the idea of reciprocity, if we think that because now the VR graph cuts across this point, the minimum of this E graph should be at the lowest point for the same distance from here. I mean, should these two distances be same as well? That answer is a no. Because you can apply, if this is zero, this is zero. This is what you can apply. But you cannot apply the other way around, because this equation is not valid. So you can have, I mean, this equation is not valid. If this equation was valid, have a look. Let's say if this equation was valid, then you could have said that E by R graph যেখানে minimum, for example, এই যে E by R গ্রাফের gradient যেখানে minimum সেটা হচ্ছে 0, সেই পজিশনে আমাদের V এর ভ্যালু সবচেয়ে কম হবে, সেই V এর minimum ভ্যালু হচ্ছে 0, because magnitude wise V এর minimum ভ্যালু কত? 0. But this equation is not even possible. This equation is not true. And also in this graph, this entire VR graph is a curve. At no position of this curve do you have a zero gradient. So how could you possibly apply this equation to find out a possible case where E is equal to 0? Because no part is zero. I mean, just have a look. Let me tell you this thing. If you draw the tangent over here and different parts of this graph and get all of these E values and invert them, plus becomes minus, minus become plus, and plot them over here, you're gonna get this exact graph. That's this what this equation all means, that the gradient of VR graph is the ER graph. বুঝছো কি বলছি?
Yes,
স্যার
sir.
বাট স্যার লাইট চার্জেস
hold your horses, একজন করে আনসার করতেছি. So this is what we're gonna get, but the question is that are we ever gonna get the, I mean, যে পয়েন্টে আমাদের গ্রেডিয়েন্টটা সবচেয়ে মিনিমাম হবে, logically should that same point also give us the minimum E point? Can we apply the reverse logic? The answer is that we cannot, because this equation doesn't agree with that. This equation does, but this equation doesn't exist.
It's invalid.
Exactly.
Thank you, sir.
Sure. হ্যাঁ, এইয়া বলো, শুভ্র কি বলতেছিলা?
স্যার কিন্তু লাইট চার্জের জন্য তাহলে কিভাবে স্যার গ্রেডিয়েন্ট 0 হচ্ছে ভি ভার্সেস আর গ্রাফের জন্য?
এই গ্রাফটা এক্সিস্টেন্স কিভাবে আসছে সেটা জিজ্ঞেস করতেছো?
না স্যার, মানে এখানে গ্রেডিয়েন্ট কিভাবে 0 হচ্ছে তাইলে?
এখানে তো গ্রেডিয়েন্ট 0
এখানে তো
গ্রেডিয়েন্ট 0 হচ্ছে এখানে যেখানে গ্রেডিয়েন্ট 0 হচ্ছে সেখানে ভ্যালুটা 0 হচ্ছে।
ঠিক আছে।
আচ্ছা, so one more thing that is left, that is this green sentence. এই সেন্টেন্সটা পড়ো সবাই, বোঝার চেষ্টা করো কি লেখা আছে। let me just zoom out a little bit. Can you read that sentence still?
Yeah, okay.
Read that sentence and try to make sense of this one. This is a valid sentence, no correction there, but try to understand what this sentence means. And this sentence is relevant to this pair of graphs, not to the bottom ones.
মানে বেসিক্যালি বলতে চাইছি যে এখানে মানে চার্জ যদি মাইনাস হচ্ছে তার মানে গ্রাফটা ফ্লিপ করবে আর কি এক্স্যাক্টলি।
ইয়া,
যেহেতু এবার পজিটিভ আছে, পজিটিভ সাইড আছে, নেগেটিভ সাইড আছে, নেগেটিভ অ্যাক্সেস হবে।
If you have plus q and if you have minus q and minus q, if both of them are minus and minus, then simply the force directions are going to revert, which means the graph that used to be on the positive axis is going to belong to the negative axis. So this is going to belong to the negative axis, is going to come to the positive axis. You're just going to have this entire shape flipped, not flipped, এটাকে যেন কি বলে, rotated, or you can say flip না, হ্যাঁ flip. You're going to have this entire graph flipped about x-axis. Equally applicable for this one as well, because in that case your individual q and small q are going to be negative, so this all of these things are going to belong to the lower side. But once again, you're going to have a point of inflection. Here the point of inflection is the lowest point. For that curve, your point of inflection is going to be the highest point. Highest point of an altogether negative graph, which means the lowest negative number. Yes, Abhias.
Sir, for minus q and minus q, the potential graph will have a maximum point, right?
Yes.
What does that really mean, sir, at that maximum point? The potential is maximum, but
Okay, I can actually entertain that question. Just for the sake of Ashan, let me just draw spheres, no big deal. If you have a scenario like this, let's say at this surface our potential is, let's say, minus 300 volt. At this surface our potential is, let's say, minus 50 volt. Somewhere over here, let's say we have a potential of minus 10 volt. Something like this. This would mean
I get it.
বুঝা গেছে?
Yes, sir. Most positive.
Comparatively, but not absolutely.
I understand, sir. Thank you.
Sure. So, any further question? Yes, বলো সামিহা।
স্যার, এর গ্রাফে হচ্ছে মিনিমাম পয়েন্ট আর দুইটার ইন্টারসেকশন পয়েন্ট, এই দুটো কি অলওয়েজ সেম হবে?
হ্যাঁ 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 হ্যাঁ, আবার বলো বুঝি নাই।
স্যার, এর গ্রাফে দুইটার ইন্টারসেকশন পয়েন্ট আর মিনিমাম পয়েন্ট যেটা দুইটা মিলে যেটা, ওই দুইটা পয়েন্ট কি সেম হবে নাকি আগে পরে হবে?
মানে ডিসটেন্স ওয়াইজ?
না স্যার, দুইটা পয়েন্ট আর এর ভ্যালুটা ওটা কি সেম হবে?
মানে এই গ্রাফের জন্য না এই পেয়ারের জন্য
নিচের পার্টে, হ্যাঁ এখানে
নিচের পেয়ারে সেম হবে না।
স্যার কেন? দুইটার মিনিমাম পয়েন্ট মানে দুইটার পয়েন্ট যেটা একই জায়গায় হবে না কেন?
মানে কোন দুইটার মিনিমাম পয়েন্ট বলতেছো? এখানে তো গ্রাফ আছে একটা।
স্যার এইটা না, এর উপরেরটা ইয়ার গ্রাফে।
আচ্ছা এই পয়েন্টটা,
এই পয়েন্টটা আর দুইটা ইন্টারসেকশন
স্যার ইন্টারসেকশন পয়েন্ট আর মিনিমাম পয়েন্ট,
এই দুইটা কি সেম?
ইন্টারসেকশন পয়েন্ট তো অবশ্যই মিনিমাম পয়েন্ট হবে। এই ইন্টারসেকশন পয়েন্টটা অবশ্যই এই মিনিমাম পয়েন্টটাই হবে। দেয়ার ইজ নো ডাউট অ্যাবাউট দিস, দিস ইজ জাস্ট বেসিক ম্যাথমেটিক্যাল অ্যাডিশন। এই ইন্টারসেকশন পয়েন্টটা অবশ্যই এই মিনিমাম পয়েন্টটা হবে। বাট what I was trying to refer that এই পয়েন্টটা আর এই পয়েন্টটা সেম হবে কিনা, দ্যাটস what I was trying to go through. এই দুটো পয়েন্ট ডেফিনেটলি সেম পয়েন্ট হবে উইদাউট এ ডাউট। বুঝছো
স্যার?
জি
আমি? হ্যাঁ
জি স্যার বুঝছি।
আচ্ছা হ্যাঁ অরুণিমা বলো।
স্যার এমন হতে পারে না যে ই এর যে মিনিমাম পয়েন্ট আর ভি এর যে মিনিমাম পয়েন্ট মানে যেখানে 0 হচ্ছে ওই দুইটা সেম, নাকি কোনোদিনও সেম হবে না?
Well, you can, if you have a ER graph having a minimum point, you cannot have a VR graph having a minimum point. You cannot have both of them. I mean, you cannot have a graph like this and simultaneously have a graph like this. You can
না
have,
না ওটা বলি নাই, বলছি যে ই এর যে মিনিমাম পয়েন্ট আর ভি এর যেখানে 0 হচ্ছে ওই দুইটা সেম পয়েন্ট, এটা কি কোনোদিনও হবে না?
এটা উইথ অ্যাপ্রোপ্রিয়েট কেসেস হইতে পারে। অ্যাপ্রোপ্রিয়েট কেসেস ফর এক্সাম্পল যদি তোমার দুটা চার্জের ভ্যালু এক্স্যাক্টলি সেম হয় তাহলে হইতে পারে, অথবা হইতে হইলে আমাদের কি ক্যালকুলেশন করে হইতে হবে। আই মিন ইট মাইট বি পসিবল টু অ্যাচিভ ইট ফর সাম pre-calculated artificially fabricated scenario, but general rule of thumb mathematically they are not supposed to be equal. I mean, I'm not sure about the answer of your question, but what I believe that with appropriate design it is possible to achieve, but is it going to be true everywhere? No.
আচ্ছা
So we are moving on to capacitors today. Are you guys up for it?
Sir, মাথা ঘোরাচ্ছে honestly.
Yeah, graphs can be something that can, I mean, actually tilt you. Okay, although we actually have 28 minutes of class time left, I'm still gonna take a vote whether you kids really can take more. So write in the chat window yes or no. I mean, yes. Put down to a vote. It's every time no. I mean, this is just one way to validate my laziness, maybe. আচ্ছা ঠিক আছে, I'm gonna let everyone go. Fine, ঠিক আছে, stop referring to the replying to the earlier question. I get your mindset, but what I really want to ask, গ্রাফের যে পার্টস গুলো বললাম এটা কি তুমি কতটুকু মনে রাখতে পারবো, দ্যাটস এ ডিফারেন্ট ইস্যু। এতক্ষণ যে জিনিসগুলো বুঝাইছি সেই জিনিসগুলো বুঝা গেছে কিনা, give me some reply about this question, যে যতক্ষণ ক্লাস হইছে ততক্ষণ বুঝা গেছে কিনা, কতটুকু তুমি মনে রাখতে পারো, কতটুকু তোমার পরে কাজে লাগবে, দ্যাটস এ ডিফারেন্ট ইস্যু। ওইটা আমরা পরে অ্যাড্রেস করবো, বাট যেটুকু আলাপ হইছে ওটুকু ধরা গেছে কিনা।
I was going in and out.
That's like 8 replies out of 70 people. Are the rest of the 70 people, I mean, left the PC screen already? How long does it take for all of you to write yes? I mean, how long does it actually take? So that we can move on and close the class. Make it happen fast.
Sir, একটা summary দেওয়া যাবে?
I really don't want to give a summary. I'll upload the
গ্রাফের পার্টটাতে একটু আরেকবার যাবেন, একটা কোশ্চেন ছিল।
আচ্ছা, I'll address your question. Let me just finish the class. Okay, kids, everyone, thank you very much for your attention. আমরা নেক্সট ক্লাসে ক্যাপাসিটর পড়াবো। ইন দ্য মিন টাইম যতদিন পর্যন্ত আমাদের ক্যাপাসিটরের ওয়ার্কশিট না দিতেছি, থার্মালের ওয়ার্কশিট যারা এখনো শেষ করো নাই, প্লিজ কিপ ওয়ার্কিং অন দ্যাট and stay safe. Thank you very much. You kids can leave. I'm stopping the recording. I'll take other questions that you can have that you are willing to ask me. the class is over. You can leave if you want.
Assalamu alaikum, sir.
Assalamu alaikum.